Yeah. Namaste everyone. Welcome to JTC Educational Revolution. This is Sumit Jamale. Now I'm going to explain you in this third video of electromagnetism, that is our activity number 3. The topic name in our Telangana board 10th class book is Lines of Magnetic Field. So same thing what have we done till now? Almost in the last video. Right, see? We kept one magnet like this. We have drawn some lines. These are called magnetic lines. Right. Okay, something like this we have drawn. Roughly I am taking here. So this region is nothing but magnetic field, and these curves are called as magnetic lines. Right, we have discussed this point already in our last video. So what are the magnetic lines? Magnetic lines are nothing but these magnetic curves are known as magnetic lines. Right, and I said you, magnetic lines can be characterized by two things: direction of the field, direction of the lines, and strength of the field, or else direction of the field and strength of the field. So how to find out the direction of the field at any point? See, I said you, direction of field at any point is in the direction of tangent at that point of curvature, if at that point of line you are at or curvature you are at. So suppose मुझे फील्ड का डायरेक्शन पता करना है कभी भी, तो सपोज मुझे यहाँ पे फील्ड का डायरेक्शन पता करना है, तो टेंजेंट ड्रॉ कर दो. जिस डायरेक्शन में टेंजेंट जाएगा उसी डायरेक्शन में फील्ड भी रहेगा. जो टेंजेंट का डायरेक्शन होगा वही फील्ड का डायरेक्शन होगा. राइट, and after that we said, if number of field lines are more in given area, then field strength will be high in that particular region. And here number of field lines are less, then field strength is less. So जहाँ का भी field line ज़्यादा होंगे, crowded होंगे, उस जगह पे field strength भी ज़्यादा रहेगा. जहाँ के भी field lines कम होंगे, उस जगह पे field strength भी कम होगा. Right? Clear everyone? चलो ये तो हो गया, पहले हमने डिस्कस किया था ये सब कुछ. अभी देखेंगे ये यूनिफॉर्म फील्ड है या नॉन यूनिफॉर्म फील्ड है. ये जो मैग्नेटिक फील्ड हमने ड्रॉ किया ये यूनिफॉर्म फील्ड है या नॉन यूनिफॉर्म, ये डिस्कस करेंगे तो ये टॉपिक हो जाएगा. सी, a field is said to be uniform field if its direction and strength remain same at every point. Okay, getting with this? Direction and strength should remain same at every point. Then that field is said to be uniform field. Right. Now non-uniform field means if anyone out of direction and strength changes, then that field is said to be non-uniform field. So मतलब यूनिफॉर्म फील्ड कब कहलाएगा? अगर स्ट्रेंथ और डायरेक्शन हर पॉइंट पे सेम रहेंगे. राइट. नॉन यूनिफॉर्म फील्ड में क्या होगा? स्ट्रेंथ और डायरेक्शन में कोई ना कोई एक चेंज होते रहेगा पॉइंट टू पॉइंट. Getting with this point everyone? Right? So ये टॉपिक बहुत इंपॉर्टेंट है डेफिनेशन एग्जाम पॉइंट ऑफ व्यू. राइट। चलो थोड़ी देर ऑब्जर्व कर लो, जो जो दिया गया समझाया गया। नाउ विल गो थ्रू आफ्टर दिस नेक्स्ट टॉपिक। ऑब्जर्व करो सभी लोगों। ओके, राइट। चलो ऑब्जर्व करो अभी सभी लोग, जब तक मैं रफ कर दूं, जब तक मैं रफ ना करूं ऑब्जर्व करते रहो। सब चलो बढ़िया है, समझ में आ गया? अंडरस्टूड एवरीवन? राइट। होप यू गॉट द थिंग्स क्लियर अप टू दिस व्हाटएवर वी डन टिल नाउ। नाउ आवर नेक्स्ट टॉपिक इज magnetic flux and magnetic flux density. Let us try to understand this. See, for this, what you have to do, we have to assume that the field is uniform field. अभी देखो हमने पढ़ा था ना, we just now read uniform and non-uniform field. So we assume that here the field is uniform field. See, uniform field will be like this. These are magnetic field lines. I'm drawing some field lines here. See here, every field line direction is same at every point. Direction is just like this, okay? And strength also same. The number of field lines in given area are same, right? So this is uniform magnetic field. So in a uniform magnetic field, you consider one plane which is perpendicular to this. See, this is one plane, one region whose area is A. एक ऐसा प्लेन मान लो, एक ऐसा जगह ले लो आप, इतना सा थोड़ा सा राउंड वाला जगह मान लो, उसका एरिया A है, राइट? सो प्लेन मतलब एक जगह, राइट? ओके, 2D क्लियर। सो कंसिडर वन प्लेन whose area is A and this plane is perpendicular to the magnetic field. ये magnetic field को कैसा है? Perpendicular है, मतलब see, you have to consider one plane whose area is A and that plane must be perpendicular to the magnetic fields. Suppose these are magnetic fields, these two markers pointing like this, then plane should be like this. This hand is plane now, so magnetic fields will go like this. So if I keep them like this, both are 90 degree or not? See, L is forming 90 degree, right? So the plane area should be A and that plane must be perpendicular to field lines. Two conditions understood everyone? Area of the plane should be A and the plane must be perpendicular to the field lines. Right? That type of plane you have to consider. Okay? Right? तो चलो यहां तक समझ में आया? हमें एक यूनिफॉर्म मैग्नेटिक फील्ड अज्यूम करना है और उस यूनिफॉर्म मैग्नेटिक फील्ड में हम एक जगह मान लेंगे, एक प्लेन मान लेंगे रेड कलर वाला। ये प्लेन का एरिया कितना होना चाहिए? ए होना चाहिए, यूनिट एरिया एक्चुअली, राइट? और ये कैसे होना चाहिए? डायरेक्शन फील्ड लाइंस को परपेंडिकुलर होना चाहिए, राइट? क्लियर? यहां तक समझ में आ गया बात? एक थोड़े सेकंड के लिए ऑब्जर्व करो इन चीजों को. ऑब्जर्व फॉर व्हाइल एवरीवन. Okay? Hope you understood now. Now we will define first magnetic flux. First we'll discuss about the magnetic flux. See, magnetic flux is nothing but number of magnetic lines passing through this area is known as magnetic flux. See how many lines are passing? 1, 2, 3, 4, 5. So magnetic flux is 5. Getting my point, everyone? So number of magnetic lines passing through the given plane of area A, right? And that plane is perpendicular. Obviously that all you should mention in definition. So simple words, if I say number of magnetic line passing through this area of plane of area A. Technical definition also I'll write, simple definition also I will write here. Right. The number of magnetic lines passing through the plane. Yeah, this is technical definition of area A perpendicular to the magnetic lines is known as magnetic flux. Right? Say number of magnetic lines passing through this plane whose area is A, which is perpendicular to the magnetic lines, that is called as magnetic flux. Right? If I write in simple words, this is technical one. The definition is technical definition. Right? Simple definition, if I say the number of magnetic lines passing through plane is called magnetic flux. Completed. That's it. Right? Getting with this point, everyone? So, जितने भी लाइन पास होंगे उसी को हम मैग्नेटिक फ्लक्स कहेंगे. जो okay, let us see in Hindi we'll try to write. जितने भी मैग्नेटिक लाइंस उस प्लेन से गुजरेंगे उन्हें और उससे ही हम मैग्नेटिक फ्लक्स कहेंगे. Getting with this point, everyone? Right? Clear? चलो अभी इतना ऑब्जर्व करो. चलो चलो जल्दी फास्ट. Don't see here and there, everyone. Okay, so इतना हो गया. Just 2 points रह गए. Let's see these 2 points. Magnetic flux is denoted by like this phi. Okay, the symbol is called as phi, and magnetic flux SI unit is Weber. What is the SI unit of magnetic flux? Weber. In shortcut we write WB. Okay everyone? Denoted by phi, SI unit is Weber. Hope this is clear to all of you. Now we'll see magnetic flux density. Magnetic flux density. See, just now I said magnetic flux definition, na? From that only we can write magnetic flux density definition. See, the number of magnetic flux or the magnetic flux passing through the plane or the passing through the area. See, the magnetic flux passing through the area, through the unit area, we should call it as unit area A, perpendicular to the field or field lines. So the magnetic flux passing through this, through the area of unit A, perpendicular to the field, is known as magnetic flux density. We can define in 2-3 ways. Means say number of magnetic flux or simply magnetic amount of magnetic flux passing through the area A is known as magnetic flux density. मतलब जितना magnetic flux पास होगा उस एरिया से उससे हम क्या कहेंगे? मैग्नेटिक फ्लक्स डेंसिटी. अगर मैग्नेटिक फ्लक्स ज्यादा पास होगा तो मैग्नेटिक फ्लक्स डेंसिटी ज्यादा है. मैग्नेटिक फ्लक्स कम पास होंगे तो मैग्नेटिक फ्लक्स डेंसिटी भी कम होगी. गेटिंग विद दिस पॉइंट एवरीवन? राइट. सो जितना मैग्नेटिक फ्लक्स पास होगा उस एरिया से उसी को हम क्या कहेंगे? मैग्नेटिक फ्लक्स डेंसिटी. ओके एवरीवन? राइट. सो मैग्नेटिक फ्लक्स डेंसिटी, वन मोर नेम इज magnetic strength induction. Different books will be going through different names. So many words will be used in this. Magnetic strength induction or magnetic field induction also. And magnetic flux density is denoted with B. It is denoted with B or denoted by B. So then magnetic flux density can be written as like this. See, magnetic flux passing through area, that means magnetic flux by area. Understood everyone? Magnetic flux by area is nothing but formula for magnetic flux density. So for this, what is the unit? SI units will be, see, flux unit is Weber. Then area unit will be meter square. Right. So SI unit is Weber per meter square. Or one more SI unit of magnetic flux density is Tesla, in the honor of the Sir Scientist Tesla. Clear with this? So Tesla was a very genius scientist, but he was a regular follower of even Bhagavad Gita also. See, SI unit is Weber per meter square, or one more unit will be Tesla. So by seeing this, we can define magnetic flux density like this also. Magnetic flux density is the ratio of magnetic flux and area of plane. So इन दोनों का रेशियो भी मैग्नेटिक फ्लक्स डेंसिटी होगा ना, तो हम ऐसे भी डिफाइन कर पाएंगे, ऐसे भी डिफाइन कर पाएंगे, दोनों करेक्ट है. Getting, we can define like this or we can define like that. Clear with this point, everyone? Still some more points I have to say you in this. Observe for a few seconds, everyone, and recollect whatever I am saying here. Observe. Don't see here and there. Observe for 1 minute. Video will be going on. Okay, so hope you got the sufficient time. So some more topics left out, let us finish that and then this video will end up, everyone. See student, from this magnetic flux density formula, can I write magnetic flux? Yes, what is magnetic flux from this? Magnetic flux is equal to B into A. Right, this is the formula for magnetic flux, but this is not general formula. Actually this formula is, we are getting this formula because we considered plane is perpendicular. But is it necessary plane should be perpendicular always? No, it's not necessary. Now plane could be with any orientation. Right. Suppose if the plane is not like this, imagine plane is like this. Is it perpendicular now? No. It making some angle theta, right? Then this formula is won't be useful that time. Actually the general formula is this one. Magnetic flux general formula is BA. Let us write upside here. 1 minute. General formula will be BA cos theta. This is general formula. Right. So earlier I considered 90 degree now. So theta you keep 90 degree, then we'll get this answer. See? BA cos 90. Cos 90 value how much? 1 or not? Cos 90 will be 1. So BA into 1, that is BA. So whenever field is perpendicular, then the magnetic flux formula will be BA. But if field is not perpendicular, it's with some other angle, then the general formula I have to remember, that is BA cos theta. Is it clear everyone? Right? Observe for a while. Yeah, for a few more seconds. You got the idea here, everyone, right? So, with this, we stop with the third video here. We'll meet in the fourth video with the coming next consecutive topics. What will we come across as per the Telangana board? Right, this is as for Telangana board, but any board students can use this in our app as well as in our YouTube channel. Right, so till then, it's a Jai Hind to everyone.